Hello, today we are talking about 3D objects again, and these are prisms that are not rectangular prisms, and pyramids and cones. You will need a calculator for this lesson. With the exception of the pi button, your phone should be a fine calculator if that's what you have. So just pause the video now if you need to go find a calculator, but be sure you have a calculator. So first thing, the following prism is a triangular prism, and the question is why? Well, when we look for the same shape that is congruent and parallel, that's the definition of a base, we have this triangle, and then we have this triangle in the back. These two triangles are congruent and they are parallel. So we're going to write down that the shape is a triangle, and it's because they are congruent and parallel, and that symbol looks like this. So that symbol is parallel. Now, one question you might have is, well, why aren't the other sides the bases? Well, when I look at the bottom, there's no other rectangle that's parallel to that bottom. The other two sides connect into that. So that's not the base. When I look at sort of the left side over here, this side again, there's no other side that's congruent to it and parallel to it. The base touches it, and then this front piece here touches it. And the exact same thing happens with the front. If we were to look at this sort of front right piece, that touches the base and it touches the left side, which means it's not parallel to those sides. So the base has to be the two triangles, the front and back. So what we're going to do is find the volume, surface area, and the volume of this shape. So the first thing I need to do is work on my surface area. So my surface area is going to be the area of the triangle. And I have a front and a back, so I actually have two of those. So I have 2 times the triangle area. Then I have the area of the bottom. And then I have the area of the left. And then I have the area of the right. Now, if you're using your formula sheet, the formula sheet will say that the surface area is 2 times b, which is b is the area of the base. So that's exactly the same thing as the area of the triangle. And then plus p, h, and p is the perimeter of the base, which means I add up all the sides of the triangle. So either way that we do this is absolutely fine, whichever way you want to think about it. So I'm going to start, though, with the area of the triangle. That's actually going to be the most difficult part. So I'm going to take this triangle right here, and I'm going to draw it sort of on the other side. And I know that on the left is 5, on the right is 5, and on the base is 6. To find the area of a triangle, which is again on your formula sheet, that's 1/2 base times height. Well, the base of my triangle is pretty simple. The base of my triangle is 6. What I don't know, however, is my height. So I'm going to draw the height in. When I draw the height in, this triangle is isosceles because I have a 5 on this side and I have a 5 on this side. So this isosceles triangle, when I draw in the height, is perpendicular to the bottom, and it also cuts that in half, which means this little piece right here, if the entire base was 6, this little piece is going to be 3. So this is my height, and so I don't know if you can see it, but I have a right triangle. I have an h, I have a 5, and I have a 3. So I'm going to use Pythagorean theorem. 3 squared plus h squared equals 5 squared. 5 is my hypotenuse, it's across from the 90. And then when I work this out, I'm going to find h. So I have h squared is equal to 16. That means h is 4. So now I know the height so that I can find the area of my triangle. So I'm going to go ahead right now and finish finding the area of my triangle. And that is 1/2 times my base, which is 6, times my height, which is 4. So when I work this out, 1/2 times 24 is 12. And my units would be centimeters squared. Again, this is the area of the triangle, or in other words, this is b, whichever formula you would like to use. So I'm going to go ahead now, and I'm going to use the second formula. And again, it doesn't matter which one you use. So my surface area is going to be 2 times my b. And I already found the b. The area of the base is 12. I just did that. And then I'm going to add the perimeter. Perimeter. I haven't really talked about perimeter. Perimeter is add up all the sides of the base. So I'm going to add up all the sides. So my perimeter is going to be 5 plus 5 plus 6. So my perimeter is going to be 16. And then I need to multiply by the height. And the height is actually the height of the prism. And the height of the prism is right here. That's the distance between the bases. That didn't work, between bases. That's what that says. Distance between the bases. So I'm going to work this out. Again, I'm going to get my calculator out. I'm going to calculate this out, and I believe what we get is, I get 24, and I think that this is 120. No, 192. And then that gives me 216. I need some units. I'm talking about area. So my area will be centimeters squared. So that's my surface area, is 216 centimeters squared. But you can see we've added an extra element. We have a little more work that we have to do. So at this point, we also need to find the volume. I went ahead and just made another diagram down here so that we can find the volume. When I say we, I actually mean you. So I want you to try this, finding the volume, but we're going to start with what the formula is for volume, and it's capital B times H, and capital B, we already know, is the area of the base, and we already know the base. In fact, we've already found the area, and then we know that height is the height of the prism, which is the distance between the bases. So go ahead right now, and I would like you to find the volume of this prism. So please pause the video now. My solution is the volume is 144 centimeters cubed. If you worked out finding the area to the base, that is on the right side of your screen. But we had already found that, so you didn't necessarily need to do that part again. I am moving on to the next page. If you need to pause to make corrections, pause now. So on the next page, we are labeling each diagram as a pyramid or a prism. So I would like you to try this one. So pause now so that you can identify each of these shapes. So I have the answers written down. The key is the pyramid has a point sort of at the top. They all kind of, the edges come in, the faces come in. Vocabulary. Sorry, if you needed to pause so you can make corrections. I'm moving on to vocabulary. So for our vocabulary, we have what's called a slant height. This should be brand new to you. If you look at that diagram, the slant height is on one of the faces. Okay, it is not the height of the pyramid. It is basically the height of that triangle. If you were to take this triangle off of the pyramid and find its height, that's the slant height of the pyramid. So number 5, I would like for you to try this one. Number 5, identifying which of these has a slant height of 5. Pause your video now, please. So that last one has a slant height of 5. In the first one, the edge is 5. In the second one, the altitude is 5. And in the last one, the slant height is 5. Number 6, is the slant height of a pyramid the same as its height? And the answer to that is no. Those are two different entities. Moving on to number 7, I would like you to try this one. Please pause your video now. For this problem, I got the slant height is 9. 8 is the actual altitude or height. And 9 is the slant height, the height of the triangular face. Moving on to the next page. So in this one, I'm going to skip reading the beginning part. I'm going to start with number 8. In a square pyramid with side lengths S, what is P? P stands for the perimeter. And what it's saying is I have a square base and each of the sides is called S. The pyramid would be coming out at you from the screen. So the the perimeter of this is just going to be S plus S plus S plus S, which is how many S's? 4. S's. That's not a 5, that's an S. Number 9, if the base of a regular pyramid has a perimeter of 6Q and its side length is 6, then the pyramid has how many sides? Okay, so up here in this first one, we had a square, which means how many sides are on the square? 4. And we knew that this was the length of each side. So in this case, the side length is 6. So this is the length, 6, which means what does Q have to be? Well, Q has to be the number of sides, which means the pyramid has Q sides. Next one, draw a line from column A to column B. If you look at your formula sheet, if you have it, then the lateral area of a pyramid is this part. And you can tell this is everything except the base. And that's what lateral area is, and we're going to talk about that more on a different day. The surface area of a pyramid is this one right here. And just so we know, L, this curly L, is the slant height that we talked about earlier. I don't know what happened to my E. So L is going to be the slant height. P is the perimeter of the base, and capital B, as before, is the area of the base. So we're going to find the surface area of this pyramid. Let's go ahead and I'm going to write my formula down from above. 1/2 P slant height plus B. So let's see what we have. P is the perimeter of the base. So let's go see if we have a perimeter. Well, those two sides are 5. That means this side is 5 and this side is 5. So my perimeter is going to be 5 plus 5 plus 5 plus 5. In other words, it's 4 5s, which is 20 inches. So I know my P. I'm going to check that guy off. L is my slant height. I'm going to erase what I have in my diagram. And my slant height is not here. My slant height, I'm going to draw in blue. It's right here. So I don't have my slant height. I've got to find that. So let's move on to B and see if we can find B. B is the area of the base. And so B is going to be 5 times 5. And that's going to be 25 inches squared. So I have my B. Let's go ahead and work on finding my slant height. Now the triangle that I'm going to use for my slant height, I'm going to go ahead and draw it in blue. I'm going to use this right triangle here. So I'm going to redraw that right triangle just to get it out of the way. I know that 7 is the straight up and down height. I know what I'm trying to find is this right here, and what I need to know is, well, how big is this? If you go back to the diagram, this part is going to be half of the whole side. So the whole side was 5, which means this part's going to be 2.5. So now all I'm going to do is Pythagorean theorem. So I have 2.5 squared plus 7 squared equals L squared, my slant height squared. So when I work this all out, I get 55.25 is L squared. I take the square root of that, and L is going to be 7.433. And you want to leave that on your calculator and use your answer button if you have an answer button. So when you're in class, you're going to want to use the answer button so that your answer is as accurate as mine. So now I also have my L. So let's go ahead and plug everything in. So my surface area is going to be 1/2 times my perimeter, which is in red over there, and that is 20, times my slant height, which is in blue, which is 7.433. And again, use all those decimal places or have it stored somewhere, plus my base, which is in green, so the area of my base is 25. And now when I pick up my calculator and I multiply that all out, I get my surface area is 74.330 inches squared. If you need more time, please pause the video here. So now we have the volume of a pyramid, and if we read those words, the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. When you look down here, we have the area of the base, we have the height of the pyramid, and we need a 1/3. So that's the formula for the volume of a pyramid. Again, if you have your formula sheet, you're welcome to use that. So we are going to do volume is 1/3 area of the base times the height. So what I would like for you to do right now, I want you to try and do this one. So please pause the video here. For volume, I got 58.333 inches cubed. If you need to pause the video to take a look at that question, please pause the video now. I'm moving on to the next page. For this one, I would like you to try this. You are going to circle the cones. So go ahead, pause the video, and circle the cones. So here I've circled the cone. It's the one on the right. Kind of looks like a pyramid, but the base is a circle. So the altitude, again, is the height of the cone, and the altitude is drawn in red right here. So in number 2, I would like you to try this one. And what you're doing, we want to find an altitude of 5. Pause the video, please. So the first one has an altitude of 5. This one, the radius is 5. And in this one, this is the slant height, like we were finding in the pyramids, is 5. Number 3, the altitude of a cone is blank equal to the slant height of the cone, always, sometimes, or never. And it can sometimes be equal, but it's not usually equal. So sometimes. Number 4, the altitude of a cone is blank, always, sometimes, or never, perpendicular to the base of the cone. And the altitude is always. Okay, so always perpendicular. And this last one, I want you to change it to a right cone. We're only going to deal with right cones. We're not going to have cones that are called oblique, where the point is sort of off to the side. We're not going to deal with those. So for the right cone, the altitude always, sometimes, or never has one endpoint at the center of the base. And for a right cone, it always has, the altitude is at the center of the base. Next page. So now we're talking about lateral area and surface area of a cone. And so, again, we're not really going to, the lateral area is the area of everything except the base. So in this formula for surface area, your lateral area is pi r times the slant height plus the area of the base. Now, for our cone, the area of a base is a circle, and the area of a circle, which again is on your formula sheet, is pi r squared. So for this number 6, it really wanted you to write what I just wrote, except instead of b for area of the base, we're going to write in pi r squared because our base is a circle and pi r squared is the area of a circle. So in number 7, the surface area of a cone, we would need to have the circumference of the base. For the surface area of a pyramid, we need the perimeter of a base. The circumference of a base is 2 pi r, or the circumference can be written as pi times diameter, and again, both of those are on our formula sheet. So moving down, we're going to find the surface area of this cone. So again, I'm going to start by writing down the formula, pi r L plus pi r squared. So let's go through and identify what we have and what we don't have. First thing I need is r. So I go look at my picture, and my r is that thing right there. My cone's upside down, but that's my r, and I don't have my r. So I need to use Pythagorean theorem, and the triangle that I have is actually this one. 15 is straight up and down, and 17 is the slant height, which means 17 is my C, or my hypotenuse. So for Pythagorean theorem, I would have r squared plus 15 squared equals 17 squared. And then I can work this out, and I get r squared plus 225 is equal to 289. Subtract your 225 from both sides, and I get r squared is 64, which tells me r is 8. So let's check off my r. My slant height, which of these numbers is my slant height? I've got 15 and I've got 17. This is my slant height, so I have that. And again, I already have my r, which is going to go right here. I'm ready to fill in my surface area formula. So I have pi times my radius, which is 8, times my slant height, which is 17. And then I'm going to add pi times my radius squared. And I'm going to work this out. I'm going to leave the pi's where they are. So I'm going to do 8 times 17, and that gives me 136. But that's how many pi's I have. And then 8 squared is 64, so I have 64 pi's. Then I'm going to add those two numbers together, my 136 and my 64, and that gives me 200 pi. And my units are centimeters squared for surface area. If you wanted to work that out and get a decimal, that's 628.318 centimeters squared. If you need more time, pause the video here, please. Now we're going to do the volume of the cone. This is the exact same cone that we were working on before, and here is the volume of a cone, but we know what the shape is of my base, and my base is a circle. The area of the circle is pi r squared. So here's the volume of a cone. Again, it's on the formula sheet. And right now, I would like you to try this one. Find the volume of the cone at the right. Pause the video now, please. My answer for volume is 320 pi centimeters cubed. You could also have written 1005.309 centimeters cubed. Pause the video here if you have questions or need to make corrections. I apologize for how long this video was, and I hope you only spent at most 30 minutes on it. Bring any questions that you have to class, and have a wonderful evening.